Hello guys, in this video we are going to discuss the solution of the problem prime pairs with target sum. So let us look at the problem statement. The problem statement says that given a number n, find out if n can be expressed as a plus b, where both a and b are prime numbers. If such a pair exists, return the values of a and b, otherwise return -1, -1 as an array of size 2. So for instance, if the n which is given to us is 10, then there exist two possibilities here, 3 and 7, 5 and 5. Now since 3 is less than 5, because of which we are returning 3 and 7. So for instance, when n is equals to 3, there isn't exist any solution, because of which we are returning -1 and -1. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to solve this problem, what we are going to do is we are going to generate a list of prime numbers, generate or prepare a list of prime numbers. So we will have a list of prime numbers. So this will be my list, and it will contain all the prime numbers less than or equals to n. Now once I have this list, so let us say this list is there with us. Once I have this list, all I have to do is I have to iterate on I. So I'm going to set I equals to 2, and then I'm going to iterate on I while I is less than n, and I'm going to check if the ith number is a prime number or not, and if it is a prime number, then this position will be set to true. If this is a prime number and primes of n minus I is also a prime number, then in such case I am going to return I comma n minus I. And let us say if this condition does not hold, then I am going to increase my ith pointer, and so on. I am going to iterate on this loop while I is less than n. We came out of this loop, but still we were not able to find the number. Then in such case I am going to return -1 comma -1. So that's the simplest logic for this problem, folks. Now as you can see, the tricky part is how do we generate all the prime numbers. So for this reason, we are going to use an algorithm, and let me discuss that algorithm. So the algorithm which we are going to use is this algorithm. So essentially, let us say we want to generate all the prime numbers ranging from 2 to 100. So we can conceptualize that we have written all the numbers in this matrix format, and now what we are going to do is we are going to start from 2. Now initially we will assume that all these numbers are prime numbers, so because of which the corresponding value will be set to true. Now we will come to 2, and then we will mark 2 as a prime number, but then all the multiples of 2 will not be a prime numbers. So because of which you can see 4, 6, 8, 10 and so on till all the way till 100, we are marking it with a different color, or in a list format we can mark it as false, indicating that these are not prime numbers. Then we are going to increase our counter. So now 2 becomes 3, and with 3 again we repeat the process. Now the first thing which we are going to check is whether 3 is a prime number or not. Since the default value for 3 is set to true, so 3 is a prime number. Now since 3 is a prime number, then as we have done with 2, all the multiples of 3 is not a prime number. So we are going to mark all the multiples of 3 as not a prime number. And similarly, we are going to repeat this process for all the numbers. And in this way, we will be able to identify all the prime numbers between 2 to 100. So this is the algorithm which we are going to use in order to identify the list of prime numbers which are less than or equals to a particular number. So now let us discuss the pseudocode for this problem, folks. So the first thing which we are going to do is we are going to generate all prime numbers. So let us say we want to generate a list of prime numbers, and let us say n is the number and n is given to us. So for this reason, what we are going to do is we are going to take an array primes, and we are going to initially set it to true for all numbers less than or equals to n. Now as we know that 0 and 1 are not a prime number, so we are going to mark 0 and 1 as false, and then we are going to iterate on prime numbers starting from 2. So while p into p is less than or equals to n, That is how we iterate on the prime numbers, or the square root of n is also one way of looking at it. Then we are going to check if this is a prime number or not. If this is a prime number, then in such case what we are going to do is we are going to take a j and we are going to start from j equals to p into p, and all the multiples of p now we are going to mark it as false. So for j less than or equals to n, primes of j equals to false, and now the next multiple of p, so the next multiple of p can be obtained by adding p to j, and in this way we will be able to generate the list of prime numbers, and towards the end we are going to return that list. Now let us look at our main code. So let us say we wanted to find a and b and n is given to us. So the first thing which we are going to do is we are going to initialize our primes. So the primes will be equals to list of primes, and here we are going to pass n to it. All we have to do is we have to iterate on I while I is less than n, and then we are going to check if primes of I and primes of n minus I. If both are set to true, then in such case we have found our pair and we are going to return that pair. So return of I comma n minus I. Otherwise we are going to return -1 comma -1. So that's the pseudocode, folks. Now let us see how we have implemented this code in C++ and Python. So first let us look at C++ implementation of it. So first we are going to generate the list of primes. So this is the function which we wrote, list of primes, and initially I'm going to set all the values to true. Now once I have set all the values to true, since we know 0 and 1 are not a prime number, so we are going to mark it as false, and then I'm going to iterate on the rest of the numbers. And using the algorithm which we have discussed, we are going to mark all the numbers which are not prime as false and all the numbers which are prime as true, and then towards the end we are going to return that prime list which we have. Now once we have that prime list with us, we are going to iterate on numbers I equals to 2 to I is less than n, and we are going to check if primes of I is true and primes of n minus I is true. If these two conditions are met, then we are going to return our answer. Otherwise, the default case -1 and -1 is what we are going to return as our answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution got accepted. Now let us look at our Python solution. So the Python solution is also the same, which is first we are generating the list of prime numbers, which is prime is equals to list of primes. And in the same way, we have generated the list of primes. And then we are iterating on primes in order to find out the pair I comma n minus I. If we found such pair, then we are returning that pair. Otherwise, we are returning -1 and -1. So that's the Python implementation, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.